हेलो टेस्ट टेस्ट ऑडियो क्लियर है। Hello everyone, welcome to GATE Academy. Good morning India. So this is Satish Kumar Drishetty, Faculty of Instrumentation from GATE Academy. How are you all? After a long gap, we are discussing this topic. I welcome to all instrumentation students to go through this topic, and I think on Global GATE Academy, after a long time I am coming. Since 1 year, I think so. Before 1 year, I took a class on Dalton series batch, that was the measurements. Okay. So today, for instrumentation students, this is completely different session. This session I am planning not for the gate instrumentation. So if gate is not there, if gate is not there, if gate is not your career, that means you have not opted GATE, graduate aptitude test engineering, that is for the electrical, EC and IN students. Suppose you are not satisfied by your performance, suppose you are not interested into the MTech, or you are not interested for the, or you are interested but you are not selected because of the rank. Okay. You are not in a position to obtain a good rank, then what is the next option? Then what is the next option for your career, for instrumentation career? So today, from today onwards, for instrumentation people, I want to discuss certain things beyond GATE. Beyond GATE. Earlier, we used to have some industrial jobs related to PLCs, SCADA, virtual instrumentation, lab view, but today, thanks to internet and thanks to machine learning, thanks to artificial intelligence, we are having some new generation for the instrumentation. So in that, one topic comes, that is the Internet of Things. I can say it is a new age of instrumentation, my dear. Gone are the days where we used to connect our hardware devices like sensors and transducers with a lot of wires to the systems and doing some testing every level, stage by stage, and if possible, thereafter we have gone to the interfacing with some signal conditioning, and thereafter we have gone conversion to digital and converting connecting to the microprocessors and microcontrollers and PLCs, and learning the coding of microprocessors, microcontrollers, PLCs, SCADA. This was the era. This what we can call it as industrial revolution. That was IN industry 3.0, but now industry revolution 4.0 came. In industry revolution 4.0, the internet is entering into the all dimensions of the engineering. Whether it is a mechanical, civil, electrical, everywhere the instrumentation or whatever may be the branch of engineering, the internet is entering. Many things are getting connected. Many things are getting connected on the internet, my dear. So in today's lecture, just as a glimpse, those who are planning to learn some technology, sir, we are fed up with the GATE competition and we are not going for the higher studies, but we want to enter into some new technologies. So the new technologies today in the market, everybody knows the artificial intelligence, machine learning, and the Internet of Things. Okay. So these are the new technologies which are coming to the market. So those who want to make this as a career, so this particular class will be useful. So I would like to ask all of you, please like this session, share this session to maximum number of the students. So here, if you see, what is IoT first of all? Today, in all these lectures, just I want to give, of course, you can use this as a awareness topic also. When you go for the interview, he may ask you, do you have the latest technologies? He may ask you the latest technologies available. So, at that time you should be in a position to know some technical words. So, I want to discuss in this Global Gate Academy sessions about the IoT, some basic agenda I have. Definitions and functional requirements, what is IoT and what its functionality, and next the motivation for the IoT, why we are going for IoT, and what is the architecture of IoT, what is the Web 3.0 view of IoT, majorly what are the applications of IoT, why being an instrumentation engineer we have to switch or we have to think about the IoT, and the pillars of IoT, and what is the DNA of IoT, device network application. DNA stands for device network and application. In the 3 words, DNA means, do not think the biological term DNA here, of course, it is somewhat related, just like in our body the growth of the body, the coding of the body is related to the DNA. In a similar way, device network and application of IoT is there, DNA of IoT. Next, what is the toolkit approach? Finally, what we have to learn, what are the toolkit approach for the end user, and what is the participation in the IoT, how an instrumentation can be collaborated with the IoT, participation in the IoT. Next, the middleware for IoT overview, and communication middleware for IoT, IoT information security. So, these all are the major agenda. Without wasting the time, I want to discuss all these things. Step by step we will go. First of all, what is the Internet of Things? Even a basic instrumentation student also should have an idea what is the Internet of Things, because today gone are the days of acquisition of the data from the sensor or transducers by using the wide connection, and today because of the distributed control system and because of the vast industries applications, we are sending the data between the devices. So, the fundamental definition of IoT is connecting everyday things embedded with electronics, software and sensors to the internet, enabling them to collect and exchange the data. So, this is the basic definition of IoT. What is Internet of Things? Internet of Things means connecting everything, everyday things. What are the everyday things? Suppose you have in your home is an everyday thing. So, your home should be connected to the internet. You are in the office, then also you want to monitor the home and you want to get the data from your home. And when you enter into the room, the electricity appliances, they should be on, and when you leave out of the home, electric appliances should be on. And still certain small things will be running in the home, like inverter will be running, fridge will be running, yes or not, even you are out of the home also. That information, what is a current reading, what is a meter reading, that you want to monitor by sitting in your office. You understand? And your vehicle is there somewhere, and the vehicle's information and the vehicle's data that you want to get on a URL. That means what? This is the next level of sensors here. Sensors, they will observe the data, they will acquire the data, and now you are going to publish the data on the web. Okay. So, if you see, connecting everyday things embedded with electronics, connecting everyday things embedded with electronics, software and sensors to the internet, enabling them to collect and exchange the data. So, we want to collect the data and we want to exchange the data between the things. What are the things? The things is not the industrial only, the things can be our basic home things also, normal home based products also, like mobile and industrial data like level automation, home based things. So, these all you want to acquire and you want to connect within them. Connecting the things with internet. When I say thing, the thing is what? It is a sensor, it is a everyday usable item in our home, everything. Okay. Sure. So, what is the internet? Basically, you people have some basic idea of internet, right? Generally, internet what it will do? Internet connects all the people, yes or not? Internet connects all the people. So, it is called internet of people. When we are using the Facebook, we are using the YouTube, we are using the WhatsApp, we are using the Telegram, we are using the Instagram. So, these all are what? These are the tools to connect the people. Similarly, IoT is what? IoT is collects the things. IoT is connects all things. So, it is called the Internet of Things, simplest definition. If the internet connects the people, Internet of Things connects the devices, all the things. So, what is the definition? The term Internet of Things has come to describe a number of technologies and research disciplines that enable the internet to reach out to the real world of physical objects. Very, very interesting. This is IoT 2008 summit. So, what it has done, this IoT has created a platform for the many researchers, whether they may be a physics background, whether they may be from software background, whether they may be a mechanical background, electrical, instrumentation, whatever may be the background. This IoT has created a platform. It has come to describe a number of technologies and research disciplines enable the internet to reach out. They are using the internet as a tool to reach out to meet the physical objects, physical parameters. Dear aspirants, that is what I am telling. In that physical parameters comes our instrumentation. So, temperature, pressure, flow, humidity, these are what? Physical. Okay. So, what is the things? Things having identities, and virtual personalities operating in smart spaces using intelligent interfaces to connect and communicate within social, environmental and user contexts. This is IoT in 2020. In IoT in 2008 it was actually a platform, but by the 2020 what happened? Things having identities and virtual personalities operating in smart spaces using intelligent interfaces to connect and communicate within social, environmental and user contexts. Earlier it was only for the researchers, those who want to do some research on a particular topic. So, they have used IoT as a tool or IoT as a platform, but today the IoT is entering into many social, environmental and other contexts also. Next, what are the basic functional requirements? So, functionalities first, IoT has created platform require device connectivity, diverse connectivity. That means what? Earlier, this is one important topic, my dear. Whenever the sensors, instrumentation students think that we know only sensors and transducers, but what is the purpose of these sensors? After measuring something or after converting one thing into one temperature to electrical, what is the next thing? Earlier you used to depend only on one particular microcontroller board or only on what a certain hardware like microprocessor or PLC, but today you can directly give this particular data to a platform called IoT. Suppose you are having some temperature of atmosphere. Every second the temperature of the atmosphere goes on changing. So, this temperature of atmosphere is a big data. So, if you give this particular data to a IoT platform, this IoT platform what it will do? It will analyze the data by using the big data analytics, and it is having its own proprietary softwares which are called machine learning and all those things. So, these all will go work together. They will give you some good clarity on the information on the temperature, the average temperature of this particular atmosphere today, or the average temperature or the mean temperature over the last 3 months or the last particular season can be taken. So, this is one important point I want to tell you, my dear. It is what? IoT platform requires diverse connectivity. Wireless options include ANT. ANT stands for interoperability. What is ANT? ANT stands for interoperability, which means that ANT plus products from multiple brands work together. This is one important point. What I am doing, multiple brands are there. Suppose if you go for the communication, if you want to send a data or if you want to connect one device to another device, what are the things we are using earlier? We are using the Bluetooth, right, when the distance is nearby. Then we went for Zigbee, then we went for Wi-Fi, then we went for different technologies. See, these different technologies are going to come together and working on a single platform, which means that interoperability products from multiple brands work together. What are the multiple brands we are having? सर मेरे कॉलेज में दैट IoT पर सर मज़ा नहीं आया था उसमें. या नाउ प्रमित बनर्जी ट्राई टू अंडरस्टैंड. आप एक लेक्चर लॉन्च कीजिए ना प्लीज IoT के. अभी वो स्टार्ट कर रहा हूँ प्राइम. IoT का क्या है? IoT दैट्स व्हाट आई एम डूइंग माय डियर. प्रमित बनर्जी व्हाट यू आर डूइंग नाउ? प्रमित बनर्जी वेयर आर यू नाउ? व्हाट यू आर डूइंग? Yeah. So, this particular topic, this particular IoT enables multiple brands to come together. See, different brands, GPRS, IRDA, LTE, NFC, RFID, Wi-Fi, WLAN, Zigbee and Z-Wave, LTE. So, these all preparing for GATE. Okay. So, this topic is not for the GATE, my dear, it is beyond the GATE examination. Suppose those who want to enter into the industry with BTech qualification, they have to enrich their education qualification with a new certification course, that is IoT. For instrumentation student, it is somewhat better platform to meet the present technological scope, of instrumentation. So, people of instrumentation can go for IoT. So, IoT platforms leverage applications. What IoT is doing? Internet of Things platforms leverage applications. Each and every particular platform is having its own advantages, right? Bluetooth, Wi-Fi, Zigbee, these are having different applications. Next, IoT platforms manage a range of devices. Different devices it can manage. Next, IoT platforms generate massive amounts of data. Next, IoT platforms require powerful analytics. These are the functionality things, my dear. What IoT can do? The IoT platforms require diverse connectivity. Different diversified devices has to be connected. IoT platforms leverage the applications. Application wise, some balancing is required. They should be compatible to specific industry. Next, IoT platforms manage a range of devices. IoT platforms generate massive amounts of data. For example, if you have milk processing company, milk processing industry is there. Already milk processing industry, that's what the instrumentation role, right? What the instrumentation will do? Instrumentation will establish an automation, yes or not? Instrumentation, what it will do? Instrumentation will perform a automation technique to the existing system or existing industry, Okay. So, IoT platforms manage a range of devices. IoT platforms generate massive amounts of the data. IoT platforms require powerful analytics. Okay. So, what is the motivation for why we have to take this particular topic IoT as a career deciding factor? To understand this IoT, motivation behind it is envision, extend, enable and excitement. These are the 4 words I chosen for motivation. What is the envision? A vision of the Internet of Things needs to provide holistic scenarios focusing on private, social and business benefits. We are developing an IoT model for existing things. There is a milk processing industry, there is a school, there is a college, there is a chemical industry, there is a cars manufacturing company. Like this, end to end many industries are there. I want to develop a model to that particular industry. Extend means what? I want to extend the technological limitations to the next level. Each and every particular technology is having its own limitation, right? So, suppose you are an instrumentation student. You are instrumentation students, you are familiar with sensors and transducers, but you are not familiar with communication things. What are the communication protocols? And being an instrumentation students, you are not familiar with the softwares. So, we want to extend our knowledge. Don't stuck only the sensors level. We have to extend what is the data coming from the sensor, what is the next level. The data of the sensors have to be processed by using some analytic softwares. That is what today the market is running on data science. And we should know what are the different ways how this data can be transmitted to your remote location. To send the data from the sensor to a remote location, we are having the n number of protocols, starting from the Bluetooth, Wi-Fi, Zigbee, IEEE and advanced protocols. These are technologies, Bluetooth, Wi-Fi, these are technologies, but behind the technologies we are having protocols. These protocols HTTP, UDP, TCP/IP, MQTT, COAP, these are some protocols. We do not know all these things as an instrumentation student. So, we should have some basic idea. We want to extend our knowledge, so that your sensor is not an isolated thing. Your sensor data has to be reached to the globe. Sensor data has to be published in a cloud. A cloud. In that cloud, we will make the computing. Do you understand, Pramit? Yeah. So, sensors, actuator, intelligent devices and other information sources with an open framework. We have to design open framework. There is already open framework may be available. Many frameworks are available, free frameworks. So, by using those frameworks, we can connect the data and we can publish. Next, old device should be enabled for new technologies. This is what I want to make. See, we want to change the age of instrumentation. The IoT has changed the age of the era of instrumentation. What it has done? The IoT has created the old device having limitations, they will be enabled for the new technologies. Next, excite. New stakeholders need to be excited to contribute to the Internet of Things. Evaluate. New approaches need to be discussed with a large variety of stakeholders and verified in industry. Industry people are doing research for the new things. So, let us see the basic architecture of IoT. What is architecture? See, this is a basic architecture of IoT, my dear. If you see the architecture of IoT, what IoT will do? What IoT is doing, my dear? The IoT is interested in connecting the physical world to the virtual world by using a communication network. In simple words, physical world means what? This is where our sensors, actuators and everything will come here. Sensors, actuators, devices, all the devices will come under this category. Okay. IoT allows the things in the physical world. In the physical world, what are the things we are having? The IoT devices, objects to interact with the virtual world. So, this is our sensor. I think is it visible clearly? So, this is our physical world. Here comes our sensors, devices, and this is a virtual world, which is our cloud. In between, we are having the network. We are connecting the physical world to the virtual network by using the communication network. IoT allows things in the physical world, IoT devices and objects to interact with the virtual world. Virtual world means what? Cloud servers. Do you understand, my dear? So, very interesting, right? We are going to merge three things. Being an instrumentation, we are familiar with sensors and transducer. And what we are doing, we are using some communication protocols and we are connecting to the computer science world. So, any IoT system built from the physical world, virtual world and a communication network. These three are the broadly basic blocks of an IoT system. Okay? So, this is a basic block diagram of IoT system. We are connecting the physical world, the things are related to physical world. So, these things are connected to the virtual world through a communication network. Okay. So, our instrumentation BTech was up to this only physical world. We have taken a sensor like RTD, thermistor, thermocouple, we have taken a strain gauge, Wheatstone bridge, we have done something, and now we want to connect that to the digital world, virtual world. We want to make some cloud computing, we want to publish this data, and I want to make analysis by using the data warehousing softwares like this. See here. If you see the block diagram of the IoT architecture, The basic architecture of IoT contains 4 things: devices, your physical world, sensors and actuators. By using the device, next comes the gateway, next comes the cloud. These are technical words, 4 things. Our field devices are connected to the cloud via a gateway. So, these are the blocks representation. I am having some board and these are some gateways. By using some communication protocols, we are publishing on the cloud. Okay. Connecting the data from the devices and through the gateway, we are making them to reach to the cloud. What is cloud? Cloud means it is a data storage. Cloud is a data storage possibility. Okay. Let us see now. If you see the IoT architecture, what is the IoT architecture, my dear? IoT architecture kaisa hoga? If you see the IoT architecture, what IoT architecture will do? I think it's clearly not visible, just let me explain. First of all, IoT devices are there, they generate general data. For example, sensors and actuating device, they will collect the data through the communication network. This is sent to the cloud server, and remember, from the cloud server it is given to the IoT application also. The data whatever you are collecting has to become a proper information, proper value. That means, suppose you are connecting the bunch of the data from the temperature sensors over the day. At the end, on the cloud will collect all the data and will give a valued information. The average temperature of this day is some 25 degrees Celsius. Okay, so there are different layers here. If you see the different layers, so this is the basic thing you can understand. A very good diagram here. Okay, if you see the first level, sensors will come. In the first level, the sensors will come. The sensors like temperature, power, humidity, these sensors. These things are connected to some gateway by using certain advanced protocols. 6LoWPAN, this is 6LoWPAN means low range, okay, low power wide range personal area network, Zigbee, RFID, NFC network, field control, NFC. Okay, so these are certain things, and then it is entering into the internet by using the Wi-Fi, mobile, DSL fiber, then finally it will go to services. 4 levels: sensor level, next the communication protocols, next the internet, and finally comes the services. So sensors are connected to the connectivity, and we are using some data oriented analytics, descriptive, diagnostic, event based action. And that application, again we are making it as a product, and this is a healthcare system. What a healthcare system is taking? It is taking the data from the sensitivity sensors, and sensor data is connected by connectivity to the analytics, and from that application platform it is going back to the field devices. So, an example of IoT implementation I want to tell you, an example of IoT implementation. Suppose in your home you are having the sensors, the processor, radio. So, these are the basic sensors. By using a gateway, what we call gateway as a hedge also. This, as a name indicates, it is a gate which creates a way. It is a gate which creates the way for the data, bunch of the data coming from the sensors and transducers and devices, sensors, processors, radio, whatever. Through the gateway, it is entering into the internet. But remember, directly between the internet and gateway, there is a proxy server. So once it enters into the internet, so we are having a web socket. So this web socket is having certain cloud server, and this cloud server is making analytics on the data, and finally it is sending a signal to the actuator. This is how the things are working, my dear. We are now connecting the actuators not with a wired. So we are using the wireless technology. And we are connecting the sensors and other process data to the actuators by using via the cloud. And overall, the data or the control action is reaching to the actuator not through our previous conventional methodologies, but now we are introducing we are making the internet as an intermediate thing to develop an action. That is what we call Internet of Things. Okay, my dear. So, if you see the service oriented architecture, this is the layer wise layer, the IoT architecture. So, first sensing layer will come. So, if you see the sensing layer, so this is a part I want to show. Yeah, I think all of you are able to see now. Ramit Banerjee, is it clear? First comes the sensing layer. In the sensing layer, we are taking the data from the sensors, many types of sensors. It can be auto vehicle sensors, GPS sensors, vision sensors, voice, text, medical sensors, pressure sensors, physical parameter, whatever the different variety of sensors. This was our actual instrumentation subject, right? In IoT, the sensors is the first stage, sensing layer. After sensing it, we are going to the network layer, because we want to connect these various sensors data via a network. So, in the network layer, we are having the gateways. There are different gateways like Bluetooth, Wi-Fi, okay, Zigbee. These are the 6 low WAN network, a different network layer having gateways. Then finally goes to the processing unit, data processing unit. In the data processing unit, we are having some bunch of CPU data warehousing, and finally it reaches to the application layer. This application layer is related to business entrepreneurs. They are getting the data to the mobile. Everybody in the mobile, they are getting the data. You suppose, for example, if you take the health sensors, today we are having the smart watch. The smart watch will give you how many number of hours you have slept and how many footsteps you have already walked, and what is your blood pressure and what is your heartbeat. Every moment it is displaying on the watch, and the data can be obtained in the computer, in the mobile also. So, this is what the IoT can go, my dear. So, being an instrumentation student, how to take this particular IoT as a career. So, the thing is, what are the other things we have to learn here? So, today just for the demand of the instrumentation, so many students are messaging me, sir, if gate is not there, then what to do? No need to be panic. For instrumentation students, if gate is not the career, there are so many other options also. For example, you can go for the new technologies like IoT, new technologies like artificial intelligence, you can learn it. And of course, I think most of all the BTech curriculums are also changed their topic. Some of the advanced topics are introduced in their syllabus. In many of BTech syllabuses, you can find the machine learning course, or you can find the Python course, you can find this artificial intelligence subject, or you can find the Internet of Things. I have seen in BTech EC or BTech instrumentation papers, I have seen this paper, IoT paper. What is the basic purpose of IoT paper? This IoT subject has to connect your sensors to the application level. It has to reach the massive application layer. So, now you think of where you can go. That means you can interface your instrumentation via communication protocols and by using some softwares. So, you have to learn some algorithms also. You have to develop an algorithm by using the tool. You can use this internet as a tool now. Internet like machine learning, artificial intelligence, you can use them as a tool, and you can analyze the data of the sensors and you can use it for an application. A doctor uses the patient's data as an application. So, for a doctor, this is an application. And similarly, a working employee, he wants to monitor his home condition every second, every moment. So, for him it becomes an application. Similarly, the auto vehicles, their information, it has to reach an application. If you have a car, the car is having all the IoT based things which send the data to the over the internet, and the company will be monitoring that. You understand? So, it is a beginning, my dear. I hope all of you understood what I mean to say. Is today's class, just I have given a brief introduction about the IoT. In coming classes, I will give you some basic idea how these IoT components are present and what is the industrial IoT, all those things. Okay, my dear. So, choose this is the next level of instrumentation. That is what I call it as new age of instrumentation. Of course, it is necessary, days are gone my dear, you have to be having some advanced technologies knowledge also when you go for interviews, being an instrumentation, even a gate interview also. The next level of instrumentation is what? Okay sir, I have studied RTD sir, I know Wheatstone bit sir, I know strain gauge sir, I know thermocouple sir, I know bridges sir, I know measurements sir. Okay yaar, what is the next thing? Already they are there. The next thing is what? We have to make the things as smart. IoT makes your instrumentation as smart. So, in a single word I can say a smart instrumentation is IoT. You understand? So, be smart, enrich your knowledge, go beyond the instrumentation, make it smart. It is a beginning. Okay? In the next lecture, I will give some more idea about the IoT. Enough for today. Thank you one and all. Jai Hind.